Good afternoon, everyone, and welcome to the lecture. This is Thermodynamics lecture number 11, and we are dealing with thermodynamic processes. In the previous class, we had seen some really interesting stuff. We had seen how we can apply the first law of thermodynamics for melting of ice as well as for boiling of water. As I told you, these laws, the first law of thermodynamics is valid whether it is solid, liquid, or gas, valid in all the states of matter. And then we had this legendary question coming from your JEE Advance of the last year. And as you can see, it was all a test of your speed, how quickly you can do it. You don't have to solve all the 4 questions, you just have to solve one, and you get +4 in a JEE Advanced paper. Remember, what we are doing is good enough for any exam that you're going to face. The only thing is you have to remember and recollect what we have done in the exam. That is the only thing that you have to do, because I've covered everything that was physically possible for me to cover in the time that I had. And there's nothing that is left. Maybe some points, some very typical questions are left, but that I have left for the time when you clear your JEE main, and we specifically target the questions on JEE Advanced. But on a level, the general questions of JEE Advanced I have covered. Is only 1 or 2 typical questions which might come. That part we will see after your JEE main. We move ahead, and now we what should I say? What is that thing that this biology student do when they have this state ball and they cut it? What do you dissection? Let's do a dissection of the different processes and see them once and for all, and try to finish this thermodynamics altogether. The first process that we are going to see is the isochoric or the isometric process. We have talked so much about this. We know everything. There may be 1 or 2 points that we will go through quickly, and I don't think we have to waste any more time. What is an isochoric process? An isochoric process is the process where the volume of the gas or the system remains constant. Yes or no? No or yes?
Yes, sir.
Now, first listen to me, then I will give you time to write. You don't have to write everything. You just have to write things in your language that you understand, whatever you understand. Isometric process. Everyone knows this, yes or no?
Yes,
Volume
sir.
is constant. So I can write the equation of the state. It will be obeying this Galile's law, yes or no? P1 by T1 will be equal to P2 by T2, yes or no?
Yes, sir.
That will be the equation of state for this. You can also have the diagram between P and V, and the diagram between P and V, which is known as the indicator diagram. Volume V would be constant, and the diagram would be a straight line which is parallel to the y-axis. There will not be any area coming under this. Yes or no? And the slope of this diagram, the indicator diagram, the slope of this indicator diagram seems to be infinite. It is in fact infinite or not defined. Yes or no? No or yes? We understand all these things.
Yes, sir.
As I told you, every process has a specific heat. There are infinite number of specific heat for a gases. For this process, the specific heat is known as a specific heat at constant volume, and that is equal to F by 2R, where F is the degree of freedom of this gas for this process. I mean, F is the degree of freedom, whether it's this process or other process. F remains same unless and until temperature becomes high and vibrational modes come into the picture. We understand these things.
Yes, sir.
I'll give you a minute to note this down step by step in the same pattern. Just write. You don't have to write equation of state. You just write P is equal to nRT. P1 V1 or P1 by T1 is P2 by T2. P is directly proportional to T, or whatever way you want to write. I'll give you a minute to note this down. Okay, then we move on to the next point. I think you have noted till. I will put all these points together so that you can note them down faster. There is something known as bulk modulus of elasticity. I have seen question on this. Bulk modulus of elasticity. Bulk modulus for anything is change in pressure divided by change in volume by original volume. That is known as bulk modulus. For this process, the bulk modulus, because there is no change in volume, the bulk modulus will be infinite. Do we understand this?
Yes, sir.
The work done in this process is zero. We understand this?
Yes, sir.
So in this process, the change in internal energy will be equal to delta Q, and delta Q will be NCV delta T. That is equal to mu into NR into delta T. Yes or no?
Yes, sir.
We have done so many questions on this. I hope you understand this. Yes or no? We understand all these points?
Yes, sir.
No one has any doubts on this. We have done so many questions on this. Yes or no?
Yes, sir.
Okay. Note it down, fatafat. We'll do a couple of questions and then we will move ahead. Let me see if I have not missed any point. Sometimes first law, this. Okay. I think everything is noted here. The only thing is sometimes they might give you the graph between V and P. So you can just note down the other graph as well. The graph between V and P. The graph between P and V, the slope is infinite. The graph between P and V, the slope, the between V and P, the slope will be 0. So I'll give you 2 minutes to note this down. We have solved almost all types of questions here. I will just give you one question. And if you can solve this question, that means every question is already done apart from this one. This question has some value, so you have to be careful. A gas has specific heat at constant pressure, Cp as 5R by 2. The volume is given, the temperature is given, and the pressure is given. It is given that an amount of heat, something is supplied to the gas. Calculate the final temperature and pressure of the gas. Remember, whenever a process takes place in a closed vessel, the process has to be isochoric. Do we understand this? Yes or no? Do you understand
Yes,
this? Okay, I'll give you 2 minutes to solve this problem. Yes,
Delta Q equals to delta U is equals to
delta Q is equal to delta U is equal to
N is PV by RT. Sir, that is PV by RT into CV into delta T. Sir,
so that is already given to you, right? 2.49 into 10 raised to the power 4 joules. Yes or no?
that is equals to N CV delta T, no sir.
N and CV will be 3R by 2 into delta T. Yes or no?
That N will be PV by RT, sir.
Correct. That N will be PV by RT. Good. PV by RT. P is known, V is known, R is known, T is known. From there, you can find out the change in temperature. Once you get the change in temperature,
T1 minus T2 minus T1
you
equals
will get
to
the final temperature. And
Yes.
you know that this is an isochoric process. So when you get the final temperature, P1 by T1 will be equal to P2 by T2. Do you understand this? These type of
Yes,
questions
sir.
do not come with so much calculation. Even if they are calculations, they will give in the simplest possible form. So that is what we need to understand. Everyone got this?
Yes, sir.
Okay, this question we have done. Let us now quickly move on to the next process. And what is the next process?
Isobaric.
Now we'll move on to isobaric process. Isobaric process. एक minute, let me see if I have anything here. Just give me isobaric process. Move on to isobaric process. Isobaric process. Now, what is an isobaric process? Here the pressure will remain constant. Yes or no?
Yes, sir.
Isobaric process. So we can write the first point. Pressure is constant. If I have to write the equation of state, how does the equation of state look like? PV is equal to nRT is always valid. Here P1 is pressure is constant, so V1 by T1 will be equal to V2 by T2. Yes or no? No, yes.
Yes, sir.
If I draw the indicator diagram will be a graph between P and V, and this graph between P and V will be a straight line which will be parallel to x-axis. Yes or no?
Yes, sir.
The slope of that graph would be 0. Yes or no? Let me draw it here. We have already done all these things. Yes or no? The slope will be 0. Yes or no? The slope of this PV graph will be equal to 0. Yes or no? In this case, the specific heat will be known as Cp. F plus 2 by 1 R. Yes or no? And here the bulk modulus, there the bulk modulus was infinite. Here the bulk modulus would be 0. Do we understand this?
Yes.
Yes or no? Yes or no? I'll give you 2 minutes to note it down. We have gone up till bulk modulus of elasticity. We have already seen the work done in this process. Yes or no? P into V2 minus V1. And we can write it in various ways. R and R into T2 minus T1. Yes or no? We already done that. Yes or no? Yes or no?
Yes, sir.
Heat required in this process will be NCV delta T. Yes or no? NCP
Yes, sir.
delta T. Yes or no? And remember, we can derive that Mayer's relation from here. How can you derive the Mayer's relation? Just look at this. Delta Q is equal to delta U plus delta W. Do we understand this?
Yes, sir.
Delta U will be N into CV. CV is R upon gamma minus 1. And work done is mu R into delta T. From there, you will get this value gamma upon gamma minus 1, which is Cp. So basically, this equation is going to give us Cp minus Cv is equal to R. Do we understand this?
Yes, sir.
You do it in any ways, you will always get this Cp minus Cv is equal to R. We have done so many questions on this. The
Yes,
reason
sir.
I have done this is because I expect that a similar question is going to land up in your JEE main, because JEE Advanced it has come in the last year, so it may not come in JEE Advanced, but it can definitely come in your JEE main. If you draw the graph between V and P, the slope will be infinite. So that is one more thing that you have to remember. I'll give you 2 minutes to note this down. Now, if you have to any process which takes place in such a way that it is open to atmosphere, it is an isobaric process. Do we understand this? Yes or no?
Yes, sir.
Apart from those processes where it is open to atmosphere, boiling process is an isobaric process. We had seen the previous question. Yes or no?
Yes, sir.
Melting of ice into water is also an isobaric process. Yes or no?
Yes, sir.
All these processes are isobaric. So remember this. We have seen the question that came in last year JEE where they were boiling water. In this question, a similar question but made for melting of ice. And I told you that when ice melts, the change in volume is very less. Yes or no?
Yes, sir.
there is some change in the volume, and on that this question is based. So this is the question at normal pressure. Normal pressure means 1 atmosphere. At normal pressure and 0 degrees Celsius, the volume of 1 kg of ice is reduced by 91 centimeter cube on melting. Latent heat of vaporization of ice is 3.4 into 10 raised to the power 5 kg joule per kg. Calculate the change in internal energy. Same question as JEE. When 2 kg of ice melts, the atmospheric pressure is given as 1 into 10 raised to the power 5 Newton per meter square. Let's see if you can give me the answer. You can give me the answer in the simplest way. You can call this change in volume as delta V. You can call this mass of the ice as M. You can call this as L, and you can call this as P. Do we understand what I'm saying here?
Yes, sir.
So you can give the answer in the shortest form. I'll give you 2 minutes to give me the answer. How much heat energy will be required? M into L, yes or no?
Yes, sir.
What will be the work done? Pressure multiplied by change in volume, yes or no?
Yes, sir.
1 kg of ice, volume changes by delta V. M kg of ice, volume will change by
Okay, M into delta V, sir.
M into P into
P into
delta V.
delta V.
So then you can write delta U will be equal to delta Q minus
Minus
delta
delta
W.
W.
So M you can take common. It will be L minus P into delta V. Just put the values, get the answer, and stay happy. Do we understand this?
Yes, sir.
Okay. That takes us to the next process. And the next process will be known as
Isothermal.
isothermal process. Isothermal process. Now, listen to me carefully. What are the conditions that are required for a process to become isothermal?
Temperature should be constant.
How can I make the temperature constant? Because sometimes it will not be directly told to you that the process is isothermal. It will not be directly told to you.
So you can use insulating walled container or
Insulating,
that's non-conducting.
non-conducting,
Non-heat conducting.
non-heat conducting,
Thermally insulated.
thermally insulated. It is a process where temperature is constant. Do we understand this? Yes or no?
Yes, sir.
Change in temperature, or I can say the change in temperature is 0. So you don't want the temperature to change. You don't want the temperature to change. Now, if you don't want the temperature to change, then what should happen? There are two conditions which are essential for a process to be isothermal. The first condition is the walls of the container must be perfectly conducting. An isothermal temperature, an isothermal process can only happen when the temperature of the system is same as the temperature of the surroundings. It has to remain like that. For that, the process must take place in a perfectly conducting environment. The walls of the container as well as the piston of the piston should be perfectly conducting. You understand this?
Yes, sir.
And the process of expansion or compression should be so slow. It should be very slow, extremely slow. If it is extremely slow, you will have enough time for heat transfer to take place between the system and the surrounding. So basically, if I just say this in a word, say this in one word, there must be a constant heat transfer. There must be a constant heat exchange between the system and the surrounding. And as soon as some heat is developed, if it is developed inside the system, it must go outside. If the system is getting cooled down, heat must come inside the system. There must be a continuous heat exchange between the system and its surroundings. To facilitate that, the walls of the container should be perfectly conducting and the process should take place very slowly so that enough time is available for heat to get in or move out. Do we understand this?
Yes, sir.
So that process, so if someone says the process is extremely slow happening in conducting walls, that is a hint that this process is going to be isothermal. Do we understand this? Yes or
Yes,
no?
sir.
No, yes.
Yes, sir.
What, sir?
Hello, sir.
Yes, sir. See, sir, there was this question that we did. It was not mentioned whether the process is isothermal, but only a small hint was given. Conducting walls. And we had to understand that conducting wall means that the process is going to be isothermal. And you can see the surrounding temperature was given. That has to be the temperature of the system. Do we understand this?
Yes, sir.
So sometimes it is not given directly whether the process is isothermal or not. They would give it indirectly. From that indirect thing, you must have to understand that the process is isothermal. Do we understand this? Have you noted this down? Yes or no? No, yes.
Yes, sir.
Then
1 minute.
the equation of state is very simple.
Sir, 1 minute.
Okay. Let me know once you are done. You've seen these PV graphs? We have seen these PV graphs and we have seen the slope of this graph. You must understand that these graphs are hyperbolic in nature. Yes or no? Rectangular hyperbola. Yes or no? We know this.
Yes, sir.
These are rectangular hyperbola graph. I have already told you that the slope of this graph at different points is different, and at any point the slope is minus P by V. Yes or no?
Yes, sir.
Okay. When pressure increases, volume decreases. When pressure decreases, volume increases. When pressure increases, volume decreases. Yes or no? I've already given you the formula of work done, so let's not waste any time on to that. Specific heat for this process. What will be the specific heat capacity for this process, or molar specific heat for this process? Remember, there is no change in temperature, so for this process the molar specific heat or specific heat will be going to be infinite. Yes or no? No, yes.
Sir, in the last one here, work done equals to LAN or log, sir?
Sorry, log. I written ln. It has to be log. It's not ln. It's log. Log to the base 10. Isothermal elasticity. Isothermal elasticity is P. Remember in that speed of sound? Do you remember that speed of sound?
Yes, sir.
The speed of sound is root over E by something, E by rho, where E I told you was the modulus of elasticity for a solid, it was Y by rho, and so that then we came to Newton's formula and Laplace's formula, and I told you that Newton said that this is an isothermal process, and therefore he gave the formula as P by rho, but then that formula was wrong, and then came Laplace and he gave, okay, it is not an isothermal process, it is an adiabatic process. That is
Yes,
this
sir.
isothermal elasticity. Do we understand this?
Yes, sir.
That is how you connect from that speed of sound wala thing. Yes or no? No, yes.
Yes, sir.
Work done is also there, so I'll just put it. I'll put it here. You understood now that I told you it's an isothermal process. The elasticity for this process is P. And
Yes,
then Laplace came and he gave the formula which we use now, which is the formula where he says that it's not an isothermal process, but it is a adiabatic process. The work done in this process, I've already given you the formula, different ways. You can write it. I hope you understand this. I'll give you a minute to note this down. Then the last thing that remains in this thing is applying the first law of thermodynamics. You know that there is no change in temperature. So change in internal energy is zero. If change in internal energy is zero, the heat given in this process will be same as the work done. Do we understand this? So someone talks about the heat in this process, it is same as the work done. Do we understand this?
yes, sir.
I'll give you a minute to note this down. Then there is this question, sir. You have n moles of an ideal gas. Number of moles is not given. You can take it as n. You have n moles of an ideal gas and the gas is going through this process. What is the net heat given? Net heat given to the system during the process. You understand the meaning of net heat?
Yes, sir.
In the entire cycle, in some process heat will be given out, in the some process heat will be given in. We'll come to cyclic process also. Net heat is nothing but the net work, yes or no? Because change in internal energy is zero. Do we know this, yes or no, for cyclic process?
Yes, sir.
To find out, basically you have to find out the work done in this process from A to B to B to C to A, and you have 2 minutes to give me the answer. Number of moles is n and the rest of the things are known to you, and we have done a lot of questions on this. In this question, you just need to find out the work done in the three process, add them, subtract them, whatever, and you get. What is the work done in this process?
0, sir.
What is the work done in this process? Which process is this? Huh?
Isothermal.
What is the work done?
It's nRT ln V2 minus V1.
What is T here?
T is T2.
nRT2. ln of V2 by V1. Yes or no? No, yes.
Yes, sir.
What is this process?
Isobaric.
What is the work done in this process?
Work done is equals to
nR into delta T, which is T1 minus T2. Yes or no?
yes, sir.
What is the total work done? Addition of these two work. And what is the net heat? That is equal to the net work because the change in internal energy is zero. Do we understand this, or this has gone above our heads? Saying bye bye, bye bye, bye bye, bye bye. I'm going, bye bye.
Understood, sir.
Pakka, sir?
Yes, sir.
Now this is the next one, and you will just note down the answer and the result. Take it as a knowledge-based question. This is what you see here is van der Waals equation for n number of moles of a gas. Under an isothermal change, what is the work done? You will have to note down this formula number A and keep it safe somewhere. This question comes, you just mark it and you go ahead with it. I'll give you 1 minute to do it. We move ahead to the next thing and the next process. What is the next process? The last process? No, not the last. What is the next process?
Adiabatic.
The next process is adiabatic process. What is peculiar about the adiabatic process?
Delta Q is equals to 0.
The adiabatic process happens in such a way that there is no exchange of heat between the system and the surrounding. Delta Q is 0. Pressure, volume, and temperature all will change. Pressure, volume, and temperature all will change. What will be the condition for a process to be perfectly adiabatic? Yes. What will be the condition for a process to be perfectly adiabatic? Yes. How can I call a process perfectly adiabatic? Remember, we'll note it down after this. Yes. When can I call a process, or what would be the initial condition? What should be the condition for a process to become a perfectly adiabatic process?
The process in which walls and piston are non-conducting.
Yes. The process must take place in an environment which is perfectly non-conducting. Since it is non-conducting, there cannot be any heat exchange between the system and its surroundings. And the process must be sudden, very fast, so that there is no time left for heat exchange to take place. In other ways, I can say in that way, an adiabatic process is the reverse of what?
Isothermal process.
It's the reverse of isothermal process. Perfect adiabatic or isothermal process is not possible. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. The next thing is equation of state. The first equation of state is PV is equal to nRT. This is always valid in all the process. Then you can write the equation of state as PV raised to the power gamma is constant. You understand this gamma? This gamma is Cp by Cv. The other way you can write this equation, you can substitute P as nRT by V, and you will get the next equation, T into V raised to the power gamma minus 1 is constant. Or you can now eliminate V from the equation and you can write P raised to the power 1 minus gamma, T raised to the power gamma as constant. All these are nothing but the equation of state. So you can either write it as you can either write it as PV is equal to nRT, in terms of all the 4 or 5 quantities, or you can write it in terms of any 2 quantities in this fashion. Do we understand this?
Yes, sir.
So it depends on how you want to write it. You can write it in any way. This is a table. I show you in a table for different gases, the different types of gases. How does the process look like? I'll have to reduce it further. And I hope you will understand for different gases, gamma is different. Monatomic gas, gamma is 5/3. Diatomic gas, gamma is 7/5. And for polyatomic gas, gamma is 4/3. Do you understand what I've written here? Yes or no? No, yes.
Yes, sir.
Okay, I'll give you 2 minutes to note this down. Then we can go and see the PV graph or the indicator graph of this. The indicator graph of this, as I told you, it looks similar to the graph of an isothermal process, but the slope is different. Do you remember this? Yes or no?
Yes, sir.
The slope of this graph is minus gamma times P by V. Yes or no? No, yes. Do you remember this? I told you this. You don't have to write everything. You just have to note the important points. The slope of this graph is minus gamma times P by V. It is gamma times more than the slope of isothermal graph. So adiabatic graph is always steeper than the isothermal graph. Do we understand this? Yes or no? No or yes?
Yes, sir.
Note it down, please. And we move on to the next step, which is the specific heat. In this case, delta Q is 0. So specific heat for this process is 0. Adiabatic elasticity. Remember that speed of sound? Adiabatic elasticity is gamma times P. The ratio between adiabatic elasticity and isothermal elasticity is equal to gamma. Just write the formula and we are done. Then we move ahead and we apply the first law of thermodynamics in this process, FLTD. Remember that delta Q is equal to delta U plus delta W. In this process, this is equal to 0. So you can say work done will be equal to negative of change in internal energy. Yes or no?
Yes, sir.
So it is negative of N CV delta T, or you can write it as negative of N into T2 minus T1 divided by gamma minus 1 into R. Do you understand how I've written this?
Yes, sir.
Or you can write it as N R upon 1 minus gamma into T2 minus T1. Or you can write it as P2 V2 minus P1 V1 upon 1 minus gamma. So you can write it in various ways. Basically, if you just remember that delta W is equal to delta U ka negative, you would be able to get to either this form or this one. Do we understand this? All these forms are derived from the same thing. Yes or no? No or yes?
Yes, sir.
This is the first law of thermodynamics applied to an adiabatic process. I hope you understand this. I'll give you a minute to note it down. Then you can compare the two processes, adiabatic and isothermal. You must understand that adiabatic process, here we are comparing the compression. Adiabatic process is always the steeper one. Adiabatic process is always the steeper one. Between 1 and 2, which is the adiabatic process and which is the isothermal process?
One is adiabatic, sir.
One is adiabatic because it is steeper The steeper one is adiabatic. So when you're talking about compression, looking at the graph, you can tell me that work done in adiabatic will be more than isothermal, pressure in adiabatic will be more than isothermal, and temperature in adiabatic will be more than isothermal temperature if the process is happening between two volumes. Do you understand this? Yes or no?
Yes.
Now you can see in the expansion process, which one will be adiabatic, 1 or 2? Which graph is adiabatic process?
2.
So work done in isothermal expansion will be more than work done in adiabatic expansion. Pressure and temperature will follow the same lead. Do we understand this?
Yes.
The gamma for monatomic gas is 1.33. The gamma for diatomic gas is 1.4, and the gamma for is written in the reverse order. Sorry, written in the reverse order. The diagram is actually reverse. The gamma for polyatomic gas is 1.3. Yes or no? 4 by 3. Do we understand this? Do we understand this?
Yes, sir.
The gamma for diatomic gas is 1.4 and the gamma for monatomic gas is 1.67. The steeper graph will be the graph of monatomic gas and the flatter graph will be the graph of polyatomic gas. Do we understand this?
Yes, sir.
In the case of adiabatic compression, which graph will be for which gas? Mono, dia, poly. Which one? For which gas?
First one is poly, sir.
First one is monoatomic, most steep. Then it is diatomic, and then it is polyatomic. Do we understand this? The steeper graph is always for the monoatomic gas. We understand this? Then we can see these graphs. The first graph is PV graph for expansion as well as compression. Do we understand these graphs? The flat line is the isobaric process. And if you draw a vertical line, this will be isochoric process. Yes or no?
Yes.
Then you can see in expansion process, adiabatic process is steeper. It goes steeper. Isothermal process is flatter. It goes flatter. But in compression, the adiabatic process is on the top and the isothermal process is below it. Do we understand this?
Yes, sir.
Same thing is written in terms of PV graph of work done in expansion process. The maximum work is done in isobaric process and minimum work is done in adiabatic process. But in compression, the minimum work is done in the isobaric process and the maximum work is done in the adiabatic process. Do we understand this?
Yes, sir.
Can we move to this table? I think everything is known in this table. Yes or no?
Yes, sir.
You just put in a tabular form. Do you want to note it down?
No, sir.
Okay, then we will move ahead and solve some question. This is the first question that comes. During adiabatic process, the pressure of the gas is found to be proportional to the cube of its absolute temperature. What is the value of gamma?
Pressure is directly proportional to T to the power of gamma by gamma minus 1, no, sir.
Yes. P into 1 minus gamma T raised to the power gamma So P raised to the power gamma into T raised to the power gamma is a constant. So basically what you can write is P into T raised to the power gamma upon 1 minus gamma is a constant. Yes or no?
Yes, sir.
And pressure is found to be proportional to the cube. So you have have I written it correctly or have I written it wrongly?
Sir, I think it's P 1 minus gamma by T gamma, sir.
Hmm?
I think.
Have I written this? No, I've written this correctly, right?
The equation is correct, but the relation is coming wrong, sir. It is P is inversely proportional to 1 by T to power of gamma.
Anyways, from here, the equation that is given is minus 3 is equal to constant, right? P is proportional to T cube.
Sir, cube is
Yes or no?
sir, it is cube, no, sir. Minus y.
What is the relation between pressure and temperature for an adiabatic process? Yes. What is the relation?
Sir, it is P power 1 minus gamma into T power of gamma equals to constant.
Have I written? So the relation that I wrote was correct. P raised to the power P raised to the power 1 minus gamma into T raised to the power gamma is a constant. Yes or no?
Yes, sir.
Now, from this relation, what you can get? If I take the
Sir,
root,
either the equation is wrong or comparison you have given is wrong, sir.
I think the comparison, no. I think the comparison has been written in the reverse order or what?
Sir, if the comparison is reverse,
I think the comparison was written in the reverse order.
then it gamma is coming to be negative, sir.
No, I think I've done a mistake somewhere. I think this equation is correct. This equation is correct. 1 minus gamma, that equation is correct. Where did I do a mistake? The answer is correct, 3 by 2, but I'm not going to get it as far as I can see it.
Sir, if answer is correct, then it should be P power gamma into T power 1 minus gamma equals to constant.
No, I don't think I've written the wrong equation. I think I've written the right equation. I can check it. We can check it using gamma. Oh yes, I've probably written it in the reverse order, I think. Probably written in the reverse order. Let me just check it. Let me just go back and check it. What equation I have given. Indicator diagram, here it was. I think I've written somewhere I've made a mistake. Right? Let me just check it. Let me check. I've given you the correct one. I can't give you the wrong one. P raised to the power 1 minus gamma, T raised to the power gamma is a constant. If I take the root, so P T raised to the power gamma upon 1 minus gamma is a constant. Here they have given pressure is directly proportional to T cube. Or I can write P into T raised to the power minus 3 is a constant. That means gamma upon 1 minus gamma is minus 3. From there, you get the value of gamma. What is gamma?
2/3, sir.
2/3.
Is it coming as 2 by 3? Sure. Then there is something wrong with the question, I guess. Maybe a misprint somewhere. Gamma has to be greater than 1. It's coming as 2 by 3? Sure.
No, sir. No.
No. Check it.
Minus 3/2 it is coming as.
Minus 3 by 2.
Yes, sir.
Sure about that? You have confused me also. I'm
Yes,
very
sir.
bad with how much it is
I'm
coming.
sure about that, sir. It is.
It will come as 3 by 2, yeah. You confused me so much. I got confused so much. 3 by 2 it will come. Given you all the correct relations, I got confused. Which relation did I give you wrong? All the relations are correct. No relation is wrong. You had
Yes, sir.
confused me so much. I got confused. Anyway, that is the answer. You will get gamma as 3 by 2. Wasted a lot of time on checking the relation because sometimes even I get confused and I might write instead of plus, I can write minus. Anyways, let us move on to the next question. This one. An ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of its original volume. Gamma is 5 by 3. What is the rise in temperature? Remember, temperature has to be always used in kelvins. So you have to use the equation PV raised to the power gamma as constant. Here, I think temperature and volume are given. So you have to use the relation between temperature and volume. T V raised to the power gamma minus 1 is constant. That is the relation. Yes or no?
Yes, sir.
So I can write T2 by T1 is equal to V1 by V2 raised to the power of gamma minus 1.
Yes, sir.
V1 by V2 becomes 27 by 8. Yes or no?
Yes, sir.
Gamma minus 1 is 5 by 3 minus 1. It is 2 by 3. So this becomes 3 by 2 ka square, 9 by 4, I think, something like that. So I think it's 27 by 8 raised to the power of 2 by 3. So your T2 becomes T1, which is 300. 27 ka cube is 3. 3 by 2 ka square, 9 by 4. I think you will get 675 from here. So the change in temperature would be 375 Kelvin. Are you getting this answer?
Sir, I'm getting it as 645, sir.
How?
Sir,
300
4
by 300 by 4 is how much?
300 by 4 is 75, sir.
75 into 9 will be how much?
sir.
I think both of us are tired. You are also tired and I am also tired. So we are making stupid mistakes. Anyways, next one. Shall we move on to the next one?
Yes, sir.
This is the next one. Gamma is given as 2.5. Volume is 1 by 8 times of the initial volume. What is the new pressure? Yes, how did you do it?
P into V power gamma equals to constant.
P into V to the power gamma is a constant. So you can say P2 by P1 will be equal to V1 by V2 raised to the power of gamma. V1 by V2 becomes 8. 8 raised to the power gamma is 5 by 2. So this becomes 2 raised to the power 15 by 2. Yes or no?
Yes, sir.
Okay. Next one. We have already discussed this. So you can give me the answer first for this one. This is a question from IIT-JEE. So give me the answer first. I hope you understand the question. Two graphs are given. You have to, these are graph for adiabatic processes. You have to tell me which graph belongs to which gas. I hope you understand the question. Yes or no? No, yes?
Yes, sir.
Give me the answer fast so that we can move ahead in life. Which option is correct?
Option B, sir.
Option B. Number 1 is diatomic gas, which is O2, and number 1 will be monatomic gas. No, number 1 will be diatomic gas and number 2 will be monatomic gas. Steeper is the monatomic one. Yes or no?
Yes.
So you can see these are the type of questions that come. I'll give you a couple of more so that we can wind up with this adiabatic process. Just give me a minute. Where is the next question? Here is the next question. Give me the answer for this one. Then I have one more lined up for you. But let me finish this graph wala question. This one. Yes, this one. Tell me the answer for this one. Simple question. What is the answer for this one? Just bacha. Which graph represents what? No answer? Shall I do it?
The B and C, sir, option.
B and C. Both are correct. Hey? One option, single option correct, bhai. How did you get two options correct?
So A and B both are steeper, no, sir? Like
Huh? A and B both are steeper? What are you saying?
A and D, sir.
Sir, only C, sir.
See, these two options are impossible. Have you seen any graph like this? Going
No,
like
sir.
this? For an adiabatic process?
No,
No.
sir.
When pressure increases, volume decreases. C and D are absolutely irrelevant graphs.
Yes, sir.
Then you have to see which graph is steeper. A is steeper, so A will be adiabatic.
Adiabatic.
And the other graphs are absolutely stupid. Do you understand this? They're
Yes, sir.
absolutely stupid graphs. Okay, this one. Do it fast. One more left. We can say bye-bye to adiabatic process once and for all. This one. I'll give you 2 minutes to solve you. To give you this one. And monatomic gas, ideal. Temperature T1 is enclosed in a cylinder fitted with a frictionless piston. The gas is allowed to expand adiabatically to temperature T2 by releasing the piston suddenly. If L1 and L2 are the length of the gas column before and after expansion, what is the ratio of T1 by T2? Look at option A and D carefully before jumping onto any conclusions. So, what is the relation that you have to use? T1 V1 raised to the power gamma minus 1 is constant. So I can write T1 or T1 by T2 will be equal to V2 by V1 raised to the power of gamma minus 1. As soon as you see this, option number C is absolutely wrong. And the only option that can be correct is option number D. Open your eyes and see it, beta. I can make a mistake in ratios. You cannot make a mistake in the ratios. Do we understand this?
Yes, sir.
What, sir? From plus 4, you end up with minus 5. From where I see, this is a loss of 9 marks. One wrong means a loss of 9 marks. That is where I see. Last one in this category. And I hope to get an answer quickly. Option B, sir. How did you get option B? We have to simply use PV raised to the power gamma as constant. Yes or no?
Yes, sir.
So P2 by P1 will be equal to V1 by V2 raised to the power of gamma. Yes or no? So P2 by P1 will be equal to V1 by V2 is 32 raised to the power of gamma. Gamma is not given. Is that so? Gamma is not given. Let us take gamma as 1.4. If gamma is 1.4, then the answer would be B. Yes or no? Only thing
Yes,
the
sir.
gamma value is not given. So I hope that is misprint somewhere. So we understand this isothermal process. I mean adiabatic process.
Yes, sir.
We have covered all types of process. One or two processes are remaining, which we will cover in the next class. Have you understood what we have done today? Yes or no? No, yes.
Yes, sir.
Okay, then in the next class, we will try to wind up this chapter. One or two more process, which we cannot do now. So we'll do it in the next class. Take care. God bless you. Bye bye.
Bye, sir. Have a good day.
Have a good day.